Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, so next chapter we focus on work, energy and power. Okay, so first of all, okay, kita tengok dulu untuk work. Work is a scalar quantity and is defined as the product of an applied force and the displacement of an object in the direction of the applied force. Okay, so kita dah tengok dalam chapter sebelum ni, kita dah jumpa untuk work done. Okay, work done by a constant force. Okay, so contohnya dekat sini you have an object here and then you have a force, so dia akan bergerak, so dia akan ada S, which is displacement. Okay, force and displacement in the same direction, the formula is W equals to F multiplied by S, which is F is force in Newton and S is displacement meter. Unit for work is joule or Newton meter. The SI unit for work is joule, J. 1 joule is equivalent to 1 Newton meter. Okay, 1 joule is the work done produced when a force of 1 Newton move through 1 meter in the direction of force. So maksudnya katakan kita ada satu force which is 1 Newton and then kita ada satu jarak displacement 1 meter. So 1 multiplied by 1 is 1. So 1 joule. So we get work. Okay. Another one is force and displacement in different direction. Okay, in different direction maknanya dia tak selari dengan satah horizontal. So for example this one, F dia kan, kalau kita tengok dekat sini, F dia ke atas macam ni. Then dia ada theta. Okay, dia ada theta ataupun dia ada sudut. So this one is force and displacement in different direction when the applied force of an object and the direction of movement of the object is not the same. Then work done can be calculated by the formula W equals to F cos theta multiplied by S. Cuma yang ni dia tak jadi F lah. Dia kena guna F cos theta. Kalau sebelum ni just F kan, force. Okay, so yang ni beza antara kita ada dua jenis lah. Kita ada dua jenis work. Okay, satu yang same direction. Maksudnya W equals to F multiplied by S, and then another one different direction, which is W equals to F cos theta multiplied by S. Okay, so example 25. Calculate the work done when a weightlifter uses a force of 1000 Newton to lift a weight to the height of 4 meter. Okay, so this one, dia bagi F is 1000 Newton and then height is 4 meter. So 1000 multiplied by 4, 4000 joule. Okay, example 26. A worker uses a horizontal force of 400 Newton to push the rubbish cart. Calculate the work done to push the cart to a distance of 2 meter on a horizontal surface. Okay, this one pun sama, which is F equals to 400 and S equals to 2. So we get 800 joule. Okay. Okay, so for example 27, a boy uses a force of 120 Newton to pull a crate along a straight corridor. The applied force is at an angle of 30 degrees with the horizontal floor. Calculate the work done by him after pulling the crate at a distance of 90 meter. So this one dia ada 30 degree with horizontal floor. So maknanya dia tak selari lah dengan horizontal floor. So this one, to calculate work done, you can use formula F cos theta multiplied by S. Okay, so 120 cos 30 degree multiplied by 90. So we get 9353 joule. Okay, so you can try solve example 28. Okay, so next is work done against gravity. In order to raise a mass of m kg vertically at a constant speed, a force of mg Newton must be applied vertically upwards to the mass. In raising the mass a distance of s meter, the work done against gravity will be W equals to mgs. So yang ni dia menggantikan mg ni dia menggantikan F. Dia still lagi sebab dia melibatkan gravity. So this one kalau sebelum ni kita guna F kan. W equals to Fs. So sekarang ni kalau dia include gravity, maksudnya dia secara vertically. Kalau sebelum ni horizontal. Bila horizontal dia tak melibatkan gravity kan. Dia tak ada tarikan gravity. So kalau dia ada work done against gravity, dia tukar pada mg. So you need to consider gravity. Okay, so example 29, find the work done against gravity when an object of mass 3.5 kg is raised through a vertical distance of 6 meter. So kalau nak tahu guna yang mana formula, dia ada vertical distance. So kalau horizontal tak perlu guna mg. So the vertical force F equals to mg, which is 3.5 multiplied by 9.81. So you get 34.335. So work done is F multiplied by S. Okay, so 34.335 multiplied by 6. Okay, so you get the work done here. Okay, so you can try solve example 30. Yang ni pun sebab dia bagi tahu against gravity. So dia ada vertical distance. So kena guna formula MGS. Okay, example 30, 31. Okay, so baca betul-betul soalan. Still use MGS. Okay, then another one is work done against friction. Okay, yang ni bila ada friction, when a body is pulled at a uniform speed on a rough surface, the work is done against the frictional force which is acting on the body due to the contact with the rough surface. Okay, so macam mana kita nak tengok kalau bila dia ada friction? Okay, example 32. A horizontal force pulls a body of mass 2.25 kg. Okay, so this one is M. A distance of 8 meter across a rough horizontal surface. Okay, dia horizontal. Okay, dia dalam kes ni horizontal. And then the coefficient of friction between the surface and the body is 0.25. Find the work done against friction. Okay, so kalau kat sini, dalam kes ni, you need to calculate. Okay, dia ada dua, vertically and horizontally. So kalau vertical, kita tengok dia ada R. Okay, we have R and W sebab dia ada daya ke atas dengan ke bawah. So R equals to W sebab dia ke atas kena sama dengan bawah, ataupun R minus W equals to 0. So R equals to W equals to mg. So M equals to 2.25 and G equals to 9.81. Okay, so you get the resolving for vertically. And then horizontally, F equals to, okay, kita ada friction kat sini, dia akan sama dengan force yang ni. Okay, dia sama. So F equals to friction equals to mu R, because we know that formula of friction is mu R. So 0.25 multiplied by R, which is this one. Kita dapat daripada sini. So we get force is 5.5181. So work done, W equals to F multiplied by S. Okay, so sebenarnya tujuan kita cari vertically ni sebab kita nak cari F kat sini. Kalau kita tak cari yang ni, kita tak dapat nilai F ni sebab nak dapatkan F ni kita boleh guna formula friction which is mu R. So kat sini dia ada nilai R. Okay, so bila nilai R ada kat sini, maksudnya kita kena cari dulu yang vertically. Tapi work done dia secara horizontal sebab dia based on horizontal surface. So yang ni just untuk nak cari nilai R and then kita nak gantikan dalam formula mu R. Okay, so this one untuk example 32 and then you try solve example 33 and 30. Okay, next example 34. A rough surface is inclined at 15 degrees to the horizontal. A body of mass 5 kg lies on the surface and is pulled at a uniform speed a distance of 75 centimeter up the surface by a force acting along the slope. If the coefficient of friction between the body and the surface is 0.4, calculate. Okay, first the work done against gravity. So kalau dia kata against gravity means dia adalah vertical. Okay, so kalau vertical, this one, first we need to find W, which is mg multiplied by S. Okay, so mg force, M is 5, so M equals to 5 and gravity equals to 9.81. Okay, then multiply by S. Okay, sekarang ni distance dia, dia kena based on F cos theta ataupun F sin theta. So since dia adalah horizontal, so 0.75 sin 15 degree. So you get the work done is 9.52 joule. Okay, so make sure kat sini you need to use apa ni, standard unit. Kalau dia bagi 75 cm, so change to meter, which is 0.75. Okay, then for B, you can nak cari untuk vertical. Okay, first kita cari dulu R. Okay, R is equals to W equals to mg cos theta. So your M is 5, G equals to 9.81 and cos 15 degree. Okay, why we find R? Because we need to find F, which is friction equals to mu R. Okay, so F equals to mu R. Mu dia dah bagi 0.4 and then R kita dapat daripada 47.38. So 18.952. So work done against friction is Fs. So we get 44.21 joule. Okay, so this one for work. Okay, next example 35. A surface is inclined at tangent inverse 3/4 to the horizontal. Okay, body mass 50 kg is put at a uniform speed. Okay, 5 meter, distance 5 meter. And then totally resistance totaling 50 Newton. Okay, so the work done against gravity and the work done against friction. Maksudnya dia nak yang gravity ni vertical, friction horizontal. Okay, first since dia bagi tangent inverse, so you can find tangent theta equals to 3/4. Daripada tangent kita boleh kira sin and cos. Okay, so W untuk against gravity, so yang ni lah kita ambil untuk yang vertical. W equals to this one kan. Okay, W equals to force multiplied by vertical distance. So force is mg. Okay, mg multiplied by 5 sin theta. So m is 50, g 9.81 multiplied by 5 multiplied by 3/4. So you get the work here. Okay, then untuk soalan B yang horizontally, so untuk horizontal dia dah bagi dah friction equals to F equals to 50. Biasa kalau dia tak bagi, kita guna formula yang mu R tu kan. Tapi yang ni since dia bagi terus friction, so kita terus ambil nilai 50. So work done against friction is F multiplied by S. So F equals to 50 and S equals to 5. Okay, so this one for work done. Example of work done. Okay, so this one condition when no work done is done. No work is done. Okay, no work is done bila objek is stationary, maknanya dia tak melakukan kerja. Bila objek tu pegun, objek is stationary, ataupun no force is applied, and then another one direction of motion is perpendicular to applied force. Okay, for example this one, pushing a wall. Okay, by definition of work, SW equals to Fs. If the distance is 0, no work is done, even if a force is applied. This means that no work is done in pushing an immovable object. So maksudnya kalau distance to 0, sebab formula untuk work done is Fs. So S ni mewakili distance. So kalau contoh kat sini object is stationary, maknanya objek tu tak bergerak, maknanya dia tak ada distance. So that's why no work is done. Okay. So another example, this one, a satellite orbiting in space. No work is done if an object is moving with uniform velocity without the action of force. Macam contohnya satelit ni dia tak ada force kan, tak ada daya. So a satellite does not work at all when travels at uniform velocity in outer space with its engine switched off. Okay, so yang ni contoh-contoh. And then another one, this one. No work is done if a man carrying a bag while walking. The applied force is upward to support the bag. Since the direction of the force and direction of motion is perpendicular to each other, therefore W equals to F cos 90 degree multiplied by S. So W equals to 0. So no work done. Maksud dia kat sini, ni lah untuk kes ni. Okay, yang ni objek stationary ni bila objek pegun, contohnya yang ni pushing a wall. Untuk contoh yang pertama ni kan, yang ni maknanya objek tu pegun, wall ni pegun kan, so dia tak bergerak. Okay, second one, no force is applied. Yang ni contoh yang satelit tu. Yang satelit tu, this one ni kan, no no force, dia tak ada tekan daya. And then last one, yang ni dia membentuk F dengan S ni membentuk sudut 90 darjah. So kalau kita kira cos 90 degree, dia akan dapat 0. So that's why this one dia kata no work is done. Kalau dia berjalan kan, sebab biasanya F dengan S ni dia mesti selari, dia tak boleh. Contohnya kat sini kan, F, this one, awak ada F, so dia mesti selari dengan S distance. Then kalau kita tengok contoh-contoh yang lain pun memang dia akan F dia akan selari dengan distance. Okay, so this one for work. So awak kena tengoklah untuk work, terutamanya kita fokus on work done.